We have the graph of f of x, and we want to sketch this graph. Again, as a first step, it's already in factored form, which is nice, but we like to write our translations on the right. So as a first step, I just move that 4 over. Moving from left to right, we take the points that we have. So we have the point on our red graph, -1, -1. We have the point 1, 1. With a rational graph, you could do the other points that they've labeled as well. Those ones are going to be easier, and those are the only 2 points you're going to need to do. We're going to add that on our original rational graph, we know that we have an asymptote here at x equals 0, and we have an asymptote here at y equals 0. So we're also going to look at how those 2 asymptotes change. But we're going to do our points first. And again, we're setting it up to do our stretches first, and then our translations second. So moving from left to right, what do we have? We have this half. That half is inside the function. It's going to be a horizontal, and it's going to be a horizontal stretch. We're going to multiply our x values by 2. Here we have a horizontal translation. It's already in factored form, so we know that we're going to be going 1 to the left. And here we have a vertical translation. We know that we're going to be going 4 down. So we've set things up. We've set things up so we can do our stretches first and then our translations second. So I'm going to multiply my x values by 2. Then I'm going to move things 1 to the left and 4 down. We now know where those points will end up. Finally, we need to figure out where our asymptotes are going to go. The nice thing on the rational graph with x equals 0 and y equals 0, when you multiply x or y by anything, can you see that it's going to stay 0? So the only thing that's going to affect your asymptotes is whether things are moved left or right or up and down. So we're moving 1 to the left. Can you see that your asymptote will move to x equals -1? And when we're moving 4 down, can you see that your horizontal asymptote is going to change to y equals -4? Just so things don't get too busy on our original graph, let's sketch our new graph on a separate grid. So let's draw our axes. With any graph with asymptotes, I find it's easiest to draw your asymptotes first. So we have our vertical asymptote, x equals -1. If you have a red pen, use it for your asymptotes. We have our horizontal asymptote at y equals -4. We can plot our points. One point at 1, -3. The other point at -3, -5. And now that you have those points, you can draw your graph towards your asymptotes. This question did say to state the domain and range of each. So for the original red graph, what we would say for our domain is everything except x can't equal 0. So they would accept just x can't equal 0. It is nice to say it's everything after that. So it's good to say that as well. Same thing with our range. It's everything but y can't equal 0. Y could be anything else. And on our blue graph, our domain now x can't equal -1, and y now can't equal -4. And we have our final equations. Some things to look at in this one. Again, one of the things that I'm really trying to stress early on is get a good handle on notation. This question was given to us in function notation. So everything here was in function notation with an f. But this is a graph that you know from your parent graph. This is one of the equations that we already know. Would you be okay when I said this red graph is the 1 over x graph? So what would this same thing look like? What would this blue equation be? How do I translate this equation here into an explicit equation? Well, to write it out, the -4 is still going to be there at the end. Afterwards, everything outside the function is going to be outside the function. What do I replace this f of 1/2 x plus 1 with? Well, if my original function was 1 over x, I can think of my original function f of x being 1 over x. And now wherever the x is, we have to replace it with a 1/2 bracket x plus 1. So this equation will be 1 over 1/2 bracket x plus 1 all on the bottom like that. So you need to be able to say, I can come up with this blue graph, whether they gave me the notation in function notation or whether they gave it to me in explicit notation. And the explicit notation here in particular, think about that. If you saw this, would you recognize this is a 1 over x graph with a horizontal stretch by 2, 1 to the left, and 4 down? Take some time after class today to think about that one and really try to wrap your head around it. Okay. Questions for practice are 7 and 11.